All right, this chapter we're starting off and we're going to look at what we call thermochemistry. So pretty much this entire chapter is something new. This first section is just about the nature of energy. Okay, so energy kind of has a crossover with physics, so we're going to do a little bit of kind of the chemistry-physics mixture in this chapter. Okay, the first blank here is thermodynamics is the study of energy and its transformations. So we're going to be talking a lot about different types of energy in this chapter. Energy is defined as the capacity to do work, and we're going to talk about what work is, or to produce heat, and we're going to talk about what heat means. Okay, remember your law of conservation of energy, which is just like the law of conservation of mass. Energy can be converted from one form to another, but can neither be created nor destroyed. You can't get it from anywhere. You can't just make it up, and you can't just lose it. Every kind of energy comes from somewhere. Portion of thermodynamics that we're going to look at is called thermochemistry, and this involves the relationship between a chemical reaction and energy and heat. So thermodynamics in general includes a lot of physics things. We're going to look mostly at just the chemistry part of it. Okay, let's look at what work is. Work is the energy used to cause an object with mass to move against a certain force. So how much work it takes to do something is how much energy it takes to move something against a certain force. So energy is defined as either work or heat. So there's the work, here's the heat. Heat is the energy used to cause the temperature of an object to increase. Now let's look at some different types of energy. First one is kinetic energy. Okay, and you should have had something like this with kinetic energy from a long time ago. Kinetic energy is the energy of motion, and it depends on mass and velocity. Kinetic energy relates to the temperature and the kinetic energy of a molecule. Okay, the more kinetic energy a molecule has, the more temperature it has. The more something moves, the more kinetic energy it has, therefore the higher the temperature. Okay, potential energy is the energy that is stored, okay, as due to a position or its composition. Potential energy in our usage for chemistry has to do with the energy that's stored in a bond or an arrangement of the different molecules. Okay, converting energy. You can convert back and forth between kinetic energy and potential energy. And the last type is electrical energy. Okay, electrical energy has to do with the energy due to electrical charges, protons and electrons, and it depends on the magnitude of your particular charge and how close the charges are together. Okay, this is where we kind of cross over a little bit into some physics stuff or some electricity, but when we talk about electrical energy, okay, the energy here goes up as my charge goes up, and when we talk about charge, you will see the letter Q, either uppercase or lowercase. Okay, and charge goes up. Your electrical energy and your distance, okay, as your distance goes down, meaning as they get closer and closer and closer together, you actually get more and more energy. They're inversely related here. If I have lots of charge, I have lots of energy. If they're very close together, you've got also lots of energy. So let's look at some practice questions. Okay, what are the terms for energy an object possesses? A, because of its motion, and B, because of its position. Well, the motion one, that is my kinetic energy, and the position, that is potential energy. Sometimes you'll see potential energy as uppercase U, but I like to use PE. What are the terms used to describe the changes of energy associated with a temperature change and moving an object against a force? Well, if we're talking about a temperature change, that is when I am dealing with heat. And when you're moving an object against a force, that term is work. All right, units of energy. The SI unit for energy is the joule. Remember, SI units are the basic standard unit for that particular measurement. It is an uppercase J in honor of James Joule, who investigated work and heat. Traditionally, energy changes accompanying reactions are expressed in calories. and you've got to be careful with that. That is a lowercase calorie, a lowercase c for the calories. Okay, calorie is defined as the amount of energy required to raise the temperature of 1 gram of water 1 degree Celsius. That is a calorie. Okay, and there are 4.184 joules exactly in 1 calorie. So calorie is just another type of unit for energy. Okay, like I mentioned a second ago, you got to be very careful with a nutritional calorie, which is an uppercase C, is actually a kilocalorie. There are 1,000 actual calories in a nutritional calorie. Okay, systems and surroundings. Some more terms here we're going to look at for energy. Okay, when we talk about reactions, there are 2 parts. You're either part of the system or part of the surroundings. Okay, a system is a part of the universe that you're interested in studying. So whatever I'm trying to look at, whatever reaction I'm studying, that's usually the system. And then your surroundings is everything else, which is the portion of the universe not involved in my particular system. And you are the one to kind of define what is a system and what is the surroundings. And the example is if you're looking at the interaction between hydrogen and oxygen in a cylinder, then H2 and O2 in the cylinder is a system. And then everything outside of that is your surroundings. Okay, types of systems. There are 3 types here. The first one is what we call an open system. Open systems are where matter and energy are exchanged. Think here like I had a pot of boiling water with no lid on it. You're exchanging matter in the form of water that's evaporating, and you're exchanging energy. That's the pan's getting hot. Okay, that's an open system. A closed system is the second type, and that is where matter is not exchanged, but energy is. So that would be like a pot of boiling water with the lid on. Now we're not exchanging the matter, the actual water, but it's still getting hot. Then we finally have an isolated system. That is where neither is exchanged. And this is like if I have a thermos that is closed. Okay, you're not exchanging matter. There's nothing getting out, and you're not exchanging energy. Nothing's getting warmer or cool or colder. So that's a isolated system. Okay, when we want to talk about transferring energy, we're talking about either work or heat. Okay, and like I said before, work is moving against a force, and we often will talk about the system doing work on your surroundings. So that would mean that, like, if this is the system, okay, in the box, and everything else is a surrounding, if your system is doing work on the surroundings, that means this is doing work on that. If your surroundings is doing work on the system, then that means your surroundings is moving whatever system I'm looking at. Okay, the other one that we all looked at was heat. Okay, heat is a way to transfer energy, and this is where you transfer heat always from hot to cold. And your difference in heat is temperature. And there are a few different temperature scales: Kelvin, degrees Celsius, and degrees Fahrenheit.